All right, hello everyone. Yes, I would definitely love to be in San Diego right now presenting in person, but this is the next best thing. This is actually a new talk that I just created, so hopefully I can iron out the kinks with a live internet audience. Let's get going. So as you may know, I'm on the board of the .NET Foundation, so I really like talking about .NET and C#. And I also like to write a lot of C# code, so I thought I'd talk about some of the new features in C# 6, 7, and 8, mostly focusing on C# 8. And a lot of this comes from my experience working on a project called a board, where I'll here, let me just bring this down here real quick. I'm dealing with two monitors, so where did it go? Oh, here we go. So a board is a ASP.NET core C# project. You got a landing page, and you have individual boards. I have a beta board that you can join, and kind of looks a little bit like GitHub. There's a reason for that. I used to work at GitHub, and I like to steal all the good ideas that they have. One thing about, so I had this thought, like, okay, I want to present some of the new features of C#, but I don't want to just, present these contrived examples. I wanted to present examples that feel somewhat realistic based on a real world example. So I thought, oh, well, Microsoft bought GitHub. I wonder if that means that they're going to rewrite GitHub in C# core. Now, of course they're not, but let's imagine for a moment that they were going to. And if they don't, maybe I'll create my own Haack Hub competitor to them. So I started building this example, and I'm going to start it off using C#3. The reason why is I want to go back in time when dinosaurs roamed the earth and attempted to write code. So an example. Wait, let's see if this works. It's weird presenting to an online audience because you can't hear anyone laugh. So my friend hooked me up with the laugh track. So we're going to present. We're going to start with C#3. I was thinking of doing it 1, but then it's really painful. But the reason why I want to start with C#3 is just to take a real world example, and then let's show how much it's improved as we move up into newer versions. So here we have a solution. It's called Haack Hub, and I have 2 projects here, hackhub.lib and hackhub.test, because we write unit tests. And in this class, we have an issue class. So you might think of an issue like a GitHub issue. We have comment, which is a comment someone makes on an issue. Both of these derive from a abstract content class, which has an ID and a text field. Really simple. I have a hub context where, oops, collapse that region. This is basically pretending, it's a class pretending to be an entity framework database context, because I didn't want to actually set it up, a whole database and all that. I just thought, okay, for demonstration purposes, we'll have this pretend context. And then we're going to have this URL helper class. So the idea here is when we want URLs to an issue or a comment, we have a separate class that does that because we're trying to keep our responsibilities separated, right? Like that's really not a responsibility of the domain class. It's a responsibility of another class to figure out what the URL to that class is. All right, so that's the setup. That's what we got so far. Oh, and we have some unit tests. So obviously the first thing we need to do is let's make sure all our existing tests, everything builds, tests pass, and then we'll start to, oh, I forgot to fix that. Okay, so in the true spirit of red, green refactor, we always start with a failing test, and then we fix the test by just changing the parameters of the test. This is how real engineering works, right? And so now when I when I remove that, okay, everything passes. Great. So let's take a look at let's start to add to this. So I was thinking about other types that I'm going to need in the class, and I came up with this idea of, okay, well, I want to add annotations, right? So an annotation, if you think of like in GitHub pull request, you can select a block of code, like several lines of code, and you can add a comment to that code. That's an annotation. Now, in my contrived example, I'm going to let you annotate comments, and I'm going to let you annotate issues. So let's add a class called annotation. Oh, look at this. So I'm using Writer, and the latest version has this interesting bug. You see, I'm clicking on name and won't let me do that. So I have to, I don't know how to work around it, so other than to just create a file. However, Writer was rewritten in .NET Core recently. It used to be mono, so it's really, really fast now, but there's still some bugs to work out. It's like, hey, it's great that you're fast, but if you don't work. So we're gonna write a comment annotation class, which inherits from annotation. So you can see that I made annotation an abstract base class that inherits from content. And we're gonna have an issue. I'm gonna just put everything in a single file for demo purposes. I tend to like to do this for related classes anyways. Comment. So with C# 3.0, we do have auto properties, so that's a good thing. Oh, and to prove that we're in 3.0, I forgot to show you. I'm gonna edit the project file. And you see here, Lang version 3 means we're C# 3. Now, I am still targeting .NET Core App 3.1 so that we get the latest .NET Core framework. I'm just targeting C# 3 just to, so that I don't accidentally use any modern features while we improve this get URL method. So I've added two concrete annotation types. So what's the next thing I need to do? Well, of course, I need to write unit tests for it. And so what I want to do is I want to update the get URL method so that we can generate URLs for the issue annotation and the comment annotation. So here's my URL helper test, and you'll notice that like the way I like to structure my unit test classes, I've written a blog post about this. I get rid of the namespaces because this is not a library you're supposed to reference, so the namespaces is just noise. I like to have a class for each concrete class, and then a class for each method that I'm going to test, and then a bunch of tests for that method or property. So in this case, we're going to add, I'm just going to insert a couple tests in here. I'll just kind of walk through one of them. So this test returns the correct URL for an issue annotation. So here we create up an issue annotation, and then we call get URL. And it's going to, we want to make sure it returns this little, the issue URL hash L3 to L10. This is actually borrowing the syntax for annotations within GitHub for linking to a set of lines of code within GitHub. Again, I like to steal all the good ideas there. Now, when I write this test, I'm going to go ahead and run it. And we would expect that the test fails because I haven't implemented that. And it does, right? Don't know anything about content. So let's go in and let's implement this. To save you from having to watch me do a bunch of typing, I'm just going to cut and paste this. Oops. Okay. All right. So what I did here is, what you can see the code doing is I'm doing all these casts, right? So first I'm going to try to cast this as an issue. If the content is an issue, then this would not be null, and then I return that. I try to cast it as a comment, try to cast it as annotation, issue annotation, and comment annotation. Now, this code isn't terrible. I mean, it's, you can kind of follow it along, but it would make a lot more sense to use a switch statement. But the problem is in C# 3, I believe in C#3, we can't do a switch statement on this because this isn't a C#3 only supports. See, and you can see here it's not giving me the option to create a switch statement because C#3 only supports constant pattern matching. So in other words, it only lets me do a switch statement on a constant value, and we don't have a constant value. We have an issue, or I mean content. So here what we're going to do is we're going to go in and we're going to edit, and we're going to, the nice thing is we live in the present, not in the past, and we can go ahead and change that version to 8. And then suddenly all this magic happens where I can go in here and convert it to a switch statement. Voila. So this is, so now we're taking advantage of a feature in, I think, C#7. We're not quite up to 8 yet. This allows us to use a type pattern to match on the content, right? So we switch on the content, and we can match on the type, and if it matches that type, we declare that variable of that type. So the way to read this is, we're switching on this content instance. If it's an issue, then you can refer to it as an issue, versus if it's a comment, you refer to it as a comment, and so on. You get the strong typing. Everything is beautiful and nice. Now, one thing I skipped over is because we're now, we jumped right up to C#8, but in C#6, we also got string annotation, string interpolation. And this is, I love string interpolation. When you're especially when you're building up big strings with a lot of variables, it just looks so much nicer. Whoops, what did I do there? There we go. Now, in this particular example, it's a modest improvement, but in a lot of code, string interpolation ends up being really nice. Okay. So now we have now we've got a switch statement, but in which we could have done in C#7. C#8 allows us to do something even cooler, which is turn this into a switch expression. So if you notice here, this is a statement, right? So this means we execute this line by line, and at the very end, we return this or we return this. A switch expression allows us to turn this into an entire expression, like so. Now, I need to kind of take a moment here and pause here and look at what's going on here. So because this is an expression, we can return this whole block. And you notice here that the order of the thing we're switching on and the switch statement is reversed from before. A switch expression is an infix operator. So infix means in between. So when you think of like, your grade school math, 3 plus 5, plus is in the middle, plus is an infix operator. Whereas a switch statement is a prefix operator. So you say switch, then you say the thing you're going to switch on. And if you recall, like, if you are a dinosaur like me, like you used to use those old calculators where you would do the reverse Polish notation, where you do the operator, the 2 numbers, and then enter, and then it would do it. So one way to remember, I used to get really confused when I was trying to do switch expressions, like, oh, how do I type it again? Because I kept typing switch the thing. It's the same pattern with if statements. So if I said if content is null, do this, right? Versus a ternary expression, var is null equals content dot is null, or is null, true, false, right? You notice that when you're doing an expression for a ternary, it becomes infix because you say content is null, then question mark true, false. So that's my way of remembering the syntax for switch. And as a little digression, I was like, oh, infix, that sounds so fancy. Like, what the heck does infix mean, right? And all it means, what I learned is that it's the same thing as postfix and suffix, but in. So, you know, when you think of a prefix, right? Pre is a great example of a prefix, right? So it changes the meaning of the word by appending something to the beginning. Suffix changes the meaning of the word by appending something to the end. And infix changes the meaning of a word by posting something in the middle. So all these terms actually come from grammar. What I learned, though, is that in English, at least standard English, there's almost no examples. In fact, in most human spoken language, there's almost no examples of infixes, something you insert in the middle of the word that changes the meaning of the word, or to affect the meaning of the word. So like a suffix that you know, like if you say sweet and sweetness, ness is a suffix. But I learned that in certain vernaculars, particularly one created by Snoop Dogg, where would turn the word house into his house or shit into shizzle, that he's actually making use of infix modifications to words to change the meaning or the tenor of the word. So I had no idea that he was such a grammarian, but I digress. All right, where was I? So one of the nice things about this expression is because it's an expression, you can actually, like, for example, set this to an expression of, you know, t, and then do all kinds of interesting things with that. Anywhere you would use expressions now, you can use switch expressions. And I also think that it just looks a lot cleaner and tighter than what we had before. Cool, let's move on. So switch expressions, one of my new favorite features of C# 8. So that's the latest version. Okay, but let's go back to, so I let the tool write this one. I want to write one by hand because it's fun. You notice here we have these, it's kind of hard to tell, but we have this similar code for getting the fragment based on the range. So I'm actually going to write a method to do that called getRangeFragment. So fragment is the portion of the URL after the hash sign. Range. So we're going to take in a range. And with switch expressions and switch statements, C# 8 also adds a set of new patterns for pattern matching. So pattern matching was introduced, I believe, in C# 7 with the type pattern, where you could say, like, some foo is type T, and then you had the variable name after that. That was a pattern matching. So if it matches that type, you get that variable populated. So we can do interesting pattern match. So C# 8 adds some really cool new pattern matching. So the one I'm going to show here is where we get to do pattern matching filters. So here, so we're going to return the range, switching on the range. In this case, we want to examine the property of range itself. So we're just going to use the discard operator here and say when, oops, escape. Whoa, I don't know what happened there. When range.start.value is range.end.value, we're going to return L, and then we can pick one, right? The start value. So if the beginning and end of the range is the same, then we're talking about a single line. Just return that line number. To save typing, I'm just gonna, I said I was gonna do this by hand, but I lied because I'm gonna just cut and paste the rest of this. I'll do one of the cases by hand, but the others I'm just going to cut and paste. So you can see when the start value is less than the end value, we return L start, L end, and then when if for some reason you did the start value greater than the end value, we really ought to throw an exception, but we're going to be nice and we're just going to fix it up for you. We know what you mean. And now I can go in here and I can just get range fragment, issue annotation, dot line number range. So now we've got a better implementation. Let me put that on the new line just to make it a little bit easier to see. And let's do that here as well. Get range fragment. What kind of comment annotation dot line of the range. Okay. So let's make sure we didn't break any code here by running our tests. I mean, this is all pre-scripted, so I really hope I don't. Hey, all our tests pass. So we're making good progress. So this is an example of a pattern where we're using a filter on the pattern. So really cool feature of C#8. But the next pattern I want to show is the property pattern. So this is kind of cool. I'm going to create a new class. I'm going to hope that this is going to let me. Oh, look at that. See, now the cursor is blinking in there, so it decided that this time it's going to work. I'm really glad I did a dry run earlier, because when that happened, I wasted a lot of time trying to figure out how do I create a new class. So we're gonna imagine a mail helper class. So this class is responsible for taking in our different content types and transforming them into plain English so that we can mail them out in emails for some reason. I say some reason because you know, I had to try to come up with a realistic real-world example, but you can only go so far when you're trying to demonstrate every feature that you find interesting in C#. So pattern property matching is not one that I'm actually using right now in any of my projects, but I found it really interesting. So, oh, I forgot to add. Let's add a new class. We're going to add a user class, because every demo and every real project has a user, right? And our user is not a content. So we're not going to implement content. This is a whole new thing, right? String name. And this is important because we have, oops. So we have this new mail helper, and it's going to take in an object O, and we want to get a description for whichever object we pass in. And so what I can do here is I can say, okay, well, similar to the type pattern where I can say, okay, well, if O is a user, but I'm going to go further and say, well, if O is a user and has a name, and then I'm going to populate var name, and you can see writer is actually very helpful, and it tells you that that var name is going to be a string. Then I'm going to return the user named name. But if the O is an issue and title, var title, the issue entitled title. So what you're seeing here is we're pattern matching based on the type and then extracting out the property into a variable. So in this case, we're matching on the name of a user. Here we're matching on the title of an issue. So I haven't actually, here, let me finish this one with the others. Out of respect for your time and mine, I will cut and paste the rest of this. If only I could code that quickly, that would be really nice, wouldn't it? Now, you know, one thing I haven't yet used this in production, because the other way I could have done this pattern is user and the user named user.name. So you see there that I could have just used the type pattern. I'm not sure why I would use the property one necessarily. I do see it being valuable if, for example, I had several types that each where I wanted to compare the properties to a constant value. So, you know, where one type where each type has different properties that sort of mean the same thing, and I just want to compare each of those to a constant value. Because I could say user name Phil. I could do a constant property pattern matching, and then, but this would only match users with the name of Phil. And as far as I know, there's no way to make this a little bit more dynamic, like other than to use you can combine this with a when filter. So when I could have said username Phil var, or sorry, username var name, when, whoops, when name equal fill, things like that, right? So you always have the ability to add extra filters on pattern matching. So I found that to be pretty cool. All right. So the next one, the next pattern is a tuple pattern. And I really like the tuple pattern. This is really cool. So imagine here, we don't really like the fact that, you know, we're switching on the range and we got this range.start value, range.end value. Well, what I could do is var start equals range.start.value, var end equals range.end.value, and then I can actually switch on that tuple. And then when let's do this. When start, oops, gotta get my block selection going. And so on. Start. So this is really cool. Oops. This really cleans things up quite a bit, doesn't it? Sorry, I can't tell if you're answering my question, but I'll assume all of you are nodding your heads like, oh yeah, absolutely, Phil. That really pulls the code together.
Yeah, there was one comment from Cecil that the new tuple syntax is really nice. So
yeah. Oh yeah, I agree, Cecil. So here, like we can, you know, obviously we can put as many tuples in there and we can match on the tuple. But what's really cool is there's also a way that, you know, I had to kind of manually deconstruct this range into a start and end. But imagine that I want to actually pass in an annotation here. And I just want to deconstruct start and end from an annotation. Well, how are we going to do that? Escape. Stop. Okay, sorry. I'm in the block selection mode. I don't like how Writer does block selection. I like the VS Code way better, but it is what it is. Okay, so if I go to annotation, there's this really cool thing where I can write a deconstructor or a deconstruct method. So not to be confused with constructors and destructors or finalizers or any of that. This is really about deconstructing a type into a tuple. So it really makes sense for types like, you know, point, things like that. That's like your prototypical example. But we're going to do this on a annotation type, excuse me. And so this is a pattern-based method. So you write this pattern, public void deconstruct, and then you have out parameters for each of the values that you want to be returned as part of the tuple. And then, and if you're not familiar with tuple support, which was added in C#7, this provides a really nice way to set two variables. So this is basically setting the start variable to the first thing here and the end variable to the second thing here. So you can set two variables at the same time like this. And this is setting this, you know, the out start, the out end, right? Start end. And now if I go back to here, let's see. Oh wait, I need to pass this in. I can actually do something even cooler here where I can deconstruct the annotation as part of the switch statement in here. So
you have annotation misspelled in your parameter list, by the way. That's why it's
doing that. Oh, okay.
That was from Ogun.
Thank you. Okay, so this is a lot to take in here, but what I've done here is I'm switching on annotation, And then in the pattern, I'm using deconstruction. So this is sort of you might call this a subclass of the tuple pattern called the positional pattern. So based on the position of these values, although I find the distinction between positional patterns and tuple patterns a little vague, and I'll explain why in a moment, because I have another positional pattern example. But now what I'm doing is I'm deconstructing the annotation into a tuple with the start and end, and then comparing those values. So hopefully that makes sense. It's really cool. So another example that I'll show is, let's go back to mail helper, and we're gonna get a description of an annotation. I'm just gonna cut and paste this method in here. So again, I'm using the constructor the tuple deconstruction on annotation. But here you notice I'm sort of using the positions, and this is called a positional pattern. So like if both of these values start and end are 0, then I'm saying, well, this is the first line. If it's 0 and then again using the discard anything, so 0 and anything, then I'm saying that the annotation starts at the very beginning of the text. And if it's underscore underscore, it starts somewhere in the middle. And the reason it's somewhere in the middle is I've already ruled out that it was the first line, and I've already ruled out that it started at the beginning. And so that by the time we get to this pattern, it has to be somewhere in the middle, potentially to the very end. So another approach to pattern matching with the switch expression. A good example of this one I've seen is like if you're building rock, paper, scissors, you might use that pattern. Okay, so just to recap, let me go back to here. So what I just covered are the various pattern matching patterns within C# 7 and 8, using the switch expression as the means of demonstrating these patterns. So we've got the is pattern, the constant pattern, the type pattern. You can do filters using the when statement, the positional patterns, property patterns, and tuple patterns. Okay. So we're going to change direction here a little bit, and I am going to add an excerpt to annotation. So if you recall, annotation is, you select the block of text and you write a comment on that block of text. So annotation derives from content, and the text here is the text that you're writing. But let's say we want to also display the text that you're highlighting, the text you're writing about. So we might call that an excerpt. And I'm going to start with the default implementation where the excerpt property just returns an empty string. And now, because I'm a good engineer, I'm going to go and write a unit test for excerpt. So let's add a class. Because I'm a great engineer, I'm not actually going to write it. I'm going to cut and paste it. Found this code on Stack Overflow, and it looks good to me. So here we have what this test is doing is we're going to create up this issue annotation. Here's the text we're annotating, here's the text of the issue we're annotating, and here's the range of the text we're annotating. And so when I grab this excerpt, what I expect is, since we're doing 1 through 4, and note that this is a zero-based index, 1 is inclusive, 4 is exclusive. So we expect this line, which is index 1, 2, and 3. So we expect these 3 lines to be in the excerpt. Now, when I run this test, again, red-green refactor, right? Here, let's just type this. I'm not so lazy I can't type .NET test, am I? We expect this test to fail because we haven't implemented it, right? Now, here's where we get to use.
Phil, there's a question here. I'm not sure if I it's the right context, but the question is, does the switch in get description work on a generic type? So rather than passing in an object, we can avoid additional casting.
The switch on, so like if you want to do a switch on type of T, so switch, no, so switch always requires, I think, an instance, but the instance could be a type variable, but I don't think it works that, I think I get what you're asking. I don't think it works that way. I'd have to try it out, because unfortunately, like, so why is that happening? Okay, here we go. So I think the question is something like this. Let's say this is, like, we don't actually have an instance. We just want to know, you know, T where T annotation, where T is an annotation. Could we then switch on T, right? Return T switch. The problem then would be that, well, what exactly are we returning, because we don't have T? Maybe we want to return the type name, in which case we would have to first get a type, our type equals type of T, and then switch on that type. And then we would need to, in the when, probably something like this. Oh gosh, I'm really diverting here. See, you're so good at nerd sniping me. So, oh, actually, we want to make that a discard probably. And then we could do something like type dot name equal whatever, then return whatever. So that's about it. Like it won't, I don't think you could do something like you know, comment annotation, because that's not going to work. I don't think it supports that sort of thing. Okay, now let me get back to where I was, or everything will be broken for the rest of this talk. Okay. All right, great question though. Now, where was I? So we are going to, we're writing an excerpt test. It failed. So now this is all setting up this new range class, which is a really cool feature, C#8, I believe. And I'm going to go implement excerpt. So let's go navigate to that. Do you want to enable dictation? No, not now. No. Okay, so in order to implement excerpt, I'm gonna do it in a method first, because normally it's a one-line implementation, but it kind of, if I do it that way, it's a lot to take in at once. So like, we'll just write this string get excerpt method, right? And what I want to do is I want to get the text of the actual text. So var, well, I'm in annotation. I don't know what the text is, because I'd have to write that on either the comment annotation or issue annotation. So we're going to do a little trick that I like to do, which is we're going to add a protected, actually, we'll add the protected abstract content. So basically, what I want to do is I want to force each of these derived types to implement this protected property. So for this one, let me get rid of this real quick. So I like to use, I'll just implement the missing members, and then we'll use this nice syntax for implementing a property where it's a get only property. We can just return comment, and in this one, we'll just return issue. So now, from the base class, I can always get at the content text. So let's go back to write get excerpt. So first, I'm going to grab the content text, because remember, I want to get an excerpt from the issue or the comment, not what the person wrote in the annotation. And now I want to get all the lines of that. So we'll just do the split method on /n. Maybe in a real project we would use regex and something a little more robust, but I think for our purposes, /n works great. And now what I want to do is I want to grab the excerpt lines And so normally what I'd have to do is maybe iterate through start and end and only grab those lines. But with the range, I can actually just index the line number range. And so if you see this, if I highlight this var, that's actually returning yet a string array. And now I can return string.join /n excerpt lines. Okay. And so I'll change this to be get excerpt. And let's see if our test passed. Yay, test pass. We're great engineers. So you can see there that there's explicit support for using ranges and index types within C#8. And in fact, there's some other cool things we can do here. Let me find our test. There's actually a shorthand support. So I can, instead of saying new range 1,4, I can do 1.4. And so that's creating a range of 1 to 4. And remember, the end part is exclusive. I can do that to all these and so on. I have a few other things I want to show about ranges that I think are cool, but I didn't. It didn't come up in my example, so this is where I just go full, just making stuff up here. So we're going to add a new test just for demonstrating this thing. So other cool range stuff. We got, let's say we got a sequence of words, 0, 1, 2, 3, 4. And I want to iterate through each one for each of our word in words. So this is what we saw before. I can just say, hey, look, I just want the second through third words, console.writeLine word. If I run that, we should see 1 and, oh, whoops, did I break something? Oh, yeah, I can't have the new there. You just type 3 dot dot. Okay, let's try again. And drum roll. Okay, so we can see the results right here in the corner, a total 1 and 2. So that's kind of cool. That's if you know like a range of things you want to iterate in any array or enumeration, you can do that. But yeah, let's give it a little divider. Imagine that we want to, there's also like some syntax for indexing from the end of a collection versus the beginning. So here we've got words, which is a collection of words. And then this little syntax, the caret syntax here is saying the third from the end to the, and in this case, 0th from the end. I want you to grab that range. And so we should see that that should be the exact same thing in this particular example. Should be, whoops, no, 2, 3, 4, that's right. So we think about it, a third from the end, 1, 2, 3, and then 0 from the end is 4, so 2, 3, 4. Now that turns out to be exactly the same thing as we could have used an open-ended range. How am I doing on time? Okay. I could have just said 2 dot dot. So starting from the third element, index 2, third, 0 base. Starting from the third element, give me everything after that. So we can see 2, 3, 4 as the result. So pretty cool syntax for dealing with ranges. And that, again, C#8. So next I want to talk about, so I really hope I pronounced this name right, but everyone's heard the apocryphal story of Tony Hoare, who mentioned the $1 billion mistake, which is null references. So he was the creator of null references. He regrets it to this day. Null references cause a crap ton of problems in code. Some modern languages like F#, they've kind of done away with null references by forcing you to handle every situation. Well, C# was written a while ago, and so they were, in C#8, we finally get this idea of nullable reference types. The name nullable reference type is kind of interesting because when you think of, it's sort of reverse of what you'd expect, right? I think of it as non-nullable reference types. But I think they're planning for the far future when the default, hopefully, is all types are non-nullable by default, and you have to opt in to make it nullable. But today, you have to opt into this feature. And the way you do it is, there's a couple ways. If you're going to build up to it, you just use a compiler directive here, nullable enable. And now you'll see that, in fact, let me, I'm also going to edit my project file and treat warning as errors. Let's see if I remember how to do that. Okay. Okay, so we'll treat warning as errors. And now let me build my project, .NET build. Okay, and we're going to see here that we have this compilation error, non-nullable property titles uninitialized. So, right, because now I've turned on nullable reference types, meaning that by default, this issue class, everything in this class should be all types are non-nullable in this class or in this file. So this string cannot be null. And because I didn't set it, we get a compilation error. Now, there's a couple ways to fix this. I could decide that, well, title is allowed to be null. So just like nullable ints, nullable value types that you've done in the past, you can now use the question mark to say, no, we do allow nulls. But let's say that, this issue comes from the database and the title is not null in the database, so I don't want the title to be null in my type. Well, then I just have to make sure that that title is set. This is in JavaScript, come on. I have to make sure that this title is set in the constructor. This is one way to do it, right? But this is just pushing the problem onto someone else, right? Whoever creates an instance of issue now has to specify non-null string to set it. And since I plan on using this type with entity framework, that's not a viable option for me. Now, one thought is I could just say it's equal to empty string. That's perfectly acceptable. But you can also do like you might say, well, it can't be null, but it can be null. And if you really lean into the exclamation mark, this is your way of telling the compiler, like, I know what I'm doing here. Let this be initialized to null because someone else, probably EF, but it also, or model binders in ASP.NET MVC, someone else is going to make sure that this is set, and you don't need to worry about it. Now, if you're switching a project from an existing code base to a nullable reference type, you can kind of just go through and add this to each file as you go, and then at the very end, when you've converted them all, you can then set it on the property level, project level. And this is where I'll show this. So you just basically say nullable enable on the project level, and then you can remove this. What I did in one of my projects is I actually set it on the project level, and then I use a regular expression search to add nullable disable to the top of each file. And then I just went through and started removing that from each file as I converted it. So this allows you to kind of ease into using nullable reference types. But nullable reference types are pretty cool. Now that I've set it on the project level, everything's going to be broken until I go through and make sure that I do the null.
While you're doing that, John posted in the notes, I think Mads Torgensen calls the exclamation point the damn it operator, as in I want it to be null, damn it.
I like that. Okay, I'm going to use that. Thank you, John. The damn it operator. So I'm going to set it to null, damn it. Okay, so let's see if I made that compile. So meanwhile, let's move on to the next step. Okay, great. So we're compiling. So let's start to see how does that affect the code. Well, let's go back to the user object that I've been building, and or sorry, not user, issue. So an issue has a creator, right? There's always someone who creates the issue. So we'll add a creator property, and rightfully we want that to be non-null, right? We don't want issues created by nobody, but we also have an assigned to property, and when a issue is created, it's possible that it's not assigned to anyone. So we're going to make that nullable. Okay, so we just add the question mark. So user. And now let's see how that comes to play in our code. So what I'm going to do is I'm going to write this method, get assigned to method here. So this method just returns a message for the assigned. And you notice here I'm taking in a proper user because this method is going to get called by another method. And I think I have a keyboard shortcut mapped to two different things that keeps getting in my way. It's really funny. Well, it's not funny to me. Okay. So here we have get issue description. Takes in an issue, and we pass in an issue assigned. And you notice here that this is being flagged. Let's see what happens when I try to build this. So, oh, issue does not. Oh, wait, did I assign to? Excuse me. Okay, so this is being flagged. Possible null reference argument. So this is what nullable reference types help, because this is showing me that, hey, look, this might be null, and you said that this cannot be null. Now, how can I fix this? Well, I could say, yeah, you know what? Assigning can be null. Go ahead and do that. But now we just push the problem here, right? Dereference of a possible null reference. Well, that's not good. Well, what I could do is I could check that that's not null first, right? So issue.assigned to is null. If it's null, we're going to return one message. This issue is nobody's problem. Or, oh, got my symbols back, reversed. Or if issue is null, then it's nobody's problem. Otherwise, we call get assigned to message. Now, this is really interesting, right? Because if you recall, assigned to is of type user, but we're passing it to this method, which demands a non-null user. But now this compiles, and I'll prove it by compiling it, because C#'s code flow analysis is able to determine that by the time if we get here, this cannot be null because we've already ruled that out. And you can see that it compiles with no warnings or errors. So that's really cool. But what if, I had this like helper method, because I'm original, is null. User. So let's see. Return null if true, otherwise false, right? So you might have seen validation methods like this where it's like validate argument, right? Or argument is not null. But in this case, we're taking in the user and we're returning true if the user is null, false if it's not. So if I go into here and say, if is null, and I call my method, you see here that we've run into this problem again, right? What's happening here? Well, the C#'s code flow analysis isn't going to flow all the way through, to every method and figure out if that's null or not. I believe we would, if it tried to, we might run into the halting problem there. So in this case, because we know that assigned to cannot be null, we could use the dammit operator here and say, yeah, issue assigned to, all right? And now everything's fine. But there's actually a better approach to this. there's a set of attributes that you can use to on your methods to give C# hints about like what your intent is, right? Because it would be it kind of sucks to go and override that when every time you call is null. So instead, what you can do is you can do a not null when false. So what this means is that this parameter that I put this attribute on is not null when the return value of this method is false. Okay, does that make sense? So when this method returns false, we know that this parameter is not null. And now if you look here, everything compiles again. Let's prove it. I don't want you to just take my word for it. Okay, so that's a pretty cool attribute. But we run into challenges when we start to deal with generic types. This is where things get really interesting. Let's go back to hub context. So if you recall, this is like my Entity Framework Core database contexting. So imagine we have a find method. Oh, whoops. Again, I'm kind of running low on time, so I'm going to copy and paste this. So here we have this possible null reference type because T cannot be null. So you might think, well, what if I just do T question mark? Well, that's not going to work because according to the language design of C#, when you have a generic parameter T, that has to be encompassing both nullable and non-nullable types. Like you can supply anything to it, and you can't constrain it to a nullable type. So we run into this situation where we can't really easily express this. So what do? Well, we have this thing where we could give the compiler a hint and tell it returns maybe null. And I found this attribute name really funny. I hope you do too. But it's basically saying that even though I can't express in the type system that this value can be null, you can trust me that it actually can be null. So it may be null, not it's maybe null. So this is useful when you have generic methods. Also comes in handy for things like if you're calling a third-party API language that was compiled without, without the nullable reference types enabled, and you are calling, from one with it. Sometimes you run into these weird things where it's like, oh, that thing can be nullable, but my project thinks it can't be, and so you need to give these hints to the compiler so the compiler does the right thing. All right, and then one last thing I want to show here is there are cases where you just can't really solve things with attributes. So imagine here that we have, let me add a new property to user called issues. Okay, so imagine that we want to be able to grab all the issues that a user has created, all the comments that a user has made. Okay, so we add this property, and then if you've played with EF Core, you know that when you load a user, it's only going to load the immediate properties of the user. If you want to load the user and all the user comments, you need to use this include and then include, right? Now, you notice here that it's flagging this user as, oh, that user is a possible null reference issue. But we know that this expression isn't actually going to get executed by EF. This expression is being used to build up a SQL statement. So it's going to examine the expression and build up a query, a SQL query based on the expression, but not actually execute the code within the query. So this is one of those situations where you just use the damn it operator to say, look, I know what I'm doing. this can't be null, it's fine. And so that's one other case where you're doing link expressions, for example, where you often need to use the dammit operator. All right, so I have one last feature I want to show, and I will try to get to it real quick. Ah, dang it. So I wonder if this works if I do it again. Oh, look at that. So all you have to do is try it again. It's like, did you try turning it on and off again? So imagine that we have this iEntity interface with ID. Oh, okay. And imagine that issue and comment implement this interface. Issue, comment, okay? Pretty standard thing, right? We've all seen this before. You got an interface, couple classes, implement an interface. Now, let's say I ship this library and it's on NuGet and it's the most used package ever. 1 billion projects depend on it. And I'm like, shoot, I really want to add another method to iEntity. But if I do that, I break everybody. So the typical way you would extend it is I might add a static class extensions. So I might add an extension method. Here we go. I'm just gonna get this. And let me add a unit test for that extension method. Damn it. Wow, that's really funny. I'll have to send that to the writer folks. Okay, so here, just to recap, so we got an extension method on iEntity that returns the entity type name with ID and the entity ID. Pretty straightforward. So with an issue with ID 42, it says issue with ID 42. Let's run the .NET test. Why is that? Okay, we see that that passes. Okay, but what happens if we want to, let's say for our issue, we're like, hey, you know what? We have a better implementation for issue. Like we don't want to use the default implementation. We want to use our better implementation. So we add this, we implement get log description issue ID with the issue name because we have more information. We know the concrete type. We're going to add more information. Now, it turns out this will, we have to update the unit test, and we're going to see that this actually, let me give the username. This is going to pass. Okay, I don't know if you can see that, but it passed. There it goes. That everything seems fine, right? This is a great way to extend interfaces, except for one issue. What happens if I'm passing this issue to some type that takes iEntity? And to simulate that, I'm just going to create an iEntity, entity equals issue. And then we're going to what do we expect get log description to return here, right? Because we know at this time, entity at runtime, it really is an issue. And what we wanted to do is we wanted to call this method. But what happens is, invalid token, that's a compiler. Oh, I must have hit a key. Okay, what happens is, I swear I'm almost done. Okay, we get a failure because it's calling the extension method. And this is one of the problems with extension methods is that extension methods are called on the declared type. So in other words, when we call get log description, because we have a reference to iEntity, even though entity really is an issue, but because we're calling a reference on iEntity, we're going to get the get log description extension method. So this is one of the This is one of the downfalls to using extension methods to extend interfaces. What we really want to do is we want to add get log description to iEntity. But if we add it like this, that breaks all existing implementations out there, and then you get a bunch of people yelling at you on the internet for breaking their code. Well, good news for you all. The C# 8 folks were really kind to us. They added something called default interface implementation. So I can actually go in here and be like, you know what? I'm adding this member to the interface, and if any types implement this interface but haven't, oops, sorry, I got the wrong one. If I can provide a default implementation for any types that didn't explicitly implement the version of this interface. So here we go. So here's my default implementation, get type name with ID. And now when I go back to this test, it should pass. And it passes. And you can see here that even though we cast this to iEntity, because it's a runtime implementation, we get the correct implementation. So it's one of the benefits for using default interfaces over extension methods to implement things like this. Now, one thing you might notice is, oh, shoot, you have iEntity on comment, you have iEntity on issue. Why don't you just put iEntity on the base class? And you're like, oh, yeah, that's not a bad idea, right? Like, what if I did that? That seems like a pretty safe change, doesn't it? Well, let's see what happens when I run my unit test. The fact that I'm even running the test probably gives you a hint that it's going to fail. So what's going on? Why did that fail? Why did moving the interface to the base class? This is one of these weird sort of implications you never think about until you add a new feature to the language, right? Which is all along, base classes do not inherit the members of their parent class's interfaces. So just to make that clear, for example, issue, which implements, derives from content, it doesn't inherit any of the members of the interfaces that content implements. Now, the reason why that's never been an issue in the past is because, well, if content implements an interface, content has to implement all its members, and therefore issue would inherit those members from content. But with default interfaces, you can now have methods on an interface that this content type doesn't implement, and therefore issue doesn't inherit that method on iEntity. So that's always been the rule. It's just that we've never had the ability to have members on an interface that you didn't do it. I imagine that this probably, the other way you might run into this if you explicitly implement interfaces. But the easy workaround here is what I would do is public virtual is, in this case, I would just have content implement this, because this is not a break and change. Put the default implementation there. And now, well, and then an issue, I need to override it. Darn it. There we go. And now, make sure I save. Now everything should be easy peasy. So it all works. That's something I actually ran into in my project, and I was like, oh, why didn't that work? And learned a little bit about how interfaces are inherited. Okay, so all of this code is on github.com/hackedhub. In fact, I put a reminder to myself to, this is a private repo that I built where if you look at each commit, so there's 30 commits. If you start from the first commit, each commit kind of walks you through everything I talked about. So these are my top speaker notes, are actually the commit messages. And you can see how I built up each feature step by step for this. I'll go ahead and make this public while we're talking here. Where is that? Oh, make public. I love this. Are you sure? Yes. Haack Hub. I understand. Make this repository. Okay, wow. Okay, so now you can go visit Haack/HackHub settings and you can check it out. And thank you for checking it out, and you stay classy, San Diego. Any questions?
Thank you, Phil. This was some really interesting stuff there. There's some things that I didn't realize that were new in C#. So not being somebody that's not in it, you know, every day. So we'll give a moment here for anybody else to ask some questions if you have any questions. So we got some comments. Awesome. Thanks for sharing. Thank you very much. Great broadcast. Things like that. But one last shout out for any questions. All right. Well, I guess there's no question. Oh, one question here from Anthony.
I do want to address this. So someone mentioned, so you can use an abstract class as a, okay, so interface now acts like an abstract class. Not quite. It acts like it in the sense that it can have an implementation, but unlike an abstract base class, you can still have multiple interfaces on a type. Now the question is, what if two interfaces have a default implementation of the same method? I don't recall what the behavior that is. I'm sure it's in the spec, and I believe it may be whichever interface is defined first, but that's always a possibility. And can you use an abstract base class as a regular class? No, so I still can't instantiate an interface. I still can't instantiate an abstract base class. So those things haven't changed. All that it means now is that if I want to add an interface method, so if you recall, especially if you did COM programming, you know, there's IUnknown 2, or IDispatch 2, IDispatch 3. You know, back in the ASP.MVC days when we were designing that, we did everything as abstract base classes because you could add members without breaking people. And we were worried that if we did everything as interfaces like iController, action result, then we would have to have iController 2, iController 3, and we didn't want that. But now with C#8, you can actually iterate on interfaces without having to create, you know, new interfaces for every little new member that you want to add. So it's a great approach to iterating on your types, your API.
Cool. All right. Well, I think that does it for questions, Phil, and we're over 6:30 time. So I just wanted to say thank you to Phil for spending some time with us today and presenting. And look forward to I'll post the recording and for everyone wherever we put it. And I will be updating you on any upcoming meetings. So again, thanks everybody for joining. Stay safe out there, stay healthy everybody, and we'll see you at the next meeting. Have a good night.
And bye everyone, thank you.